Hello, today we're going to be talking about sign numbers. So sign magnitude is a binary representation of both positive and negative numbers. On the other hand, unsigned magnitude is a representation of only positive numbers, which means that the most significant bit does not represent sign. So the most significant bit is the leftmost bit of your number. So if you have something like 0, 1, 1, 1, 0 would be your most significant bit. When your most significant bit is 0, that means that you have a positive number, but when your most significant bit is 1, that means that you have a negative number. So that bit represents the sign. So one's complement is the first representation of sign magnitude that we'll go over. And the steps for this is if your number is negative, then you flip all of the bits. So all of your zeros become ones, and all of your ones become zeros. So taking a look at this example, we'd like to convert -10 to 1's complement. So our first step is to convert this decimal number to binary. So -10 in binary is 0, 1, 0, 1, 0. And then we do our next step, which is just to flip the bits, and all of our zeros become ones and our ones become zeros. And so we end up with this number and we're done. So an important thing to note here is that I used 5 bits to represent this number, and that's because our most significant bits is the sign of our number. So 4 bits, the range changes from 0 to 15 to 0 to 7 because our last bit is used for our sign. Okay, so our next example is converting 10 to 1's complement, and so the crucial part here is that if the number is negative, we flip it. So if it's not, all you have to do is convert it to binary, and then you're done. Our next representation of sign magnitude is 2's complement, and the steps are similar. So if your number is negative, you first find 1's complement, and then you add 1. So in this case, if we wanted to convert 10 to 2's complement, it's the same thing. You just convert it to binary, and then you're done. So our next example will be converting -10 to 2's complement, and you first convert this number to binary. So that's the same as before, and then you flip the bits. Again, that's the same as before. This process was 1's complement. And then the difference is after you find 1's complement, you add 1. So if we add 1 to this number, we end up with 1, 0, 1, 1, 0, and then we're done.